We're given a circuit with a lot of resistors in it, and then one hint about the current through one of the resistors. And then we're asked to determine the power through one of the other resistors. How do we determine what the supply voltage is supposed to be? Find out right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering, at your service. On this problem, we have a circuit that's provided. It's a lot of resistors. Let's point out first off, I've got a power supply, a DC voltage, a DC power supply, 15 ohm, 25, 7 ohm, a 6.5 ohm, a 9 ohm resistor, a 5 ohm, 13 ohm, 15, 8 ohm, 15, and 25 ohm in this circuit. We're given that there is 1 ampere going through this 8 ohm resistor, and the question is, from this information, determine what the V sub S power supply voltage is, and also find out the power through this 25 ohm resistor right here. So this is an interesting little problem that we can work out one step at a time. You could go through this and use you could use the KVL and KCL, and in fact I'm going to do a little bit of KCL and KVL, but this is going to be a little bit easier than we imagine. You don't have to do any of these circuit loops or anything like this. You can work this out just from this information right here. So the first little bit of information that I have, these are all nodes right here. Let's make sure that that's clear. I'm going to call this node right here ground. I'm going to establish that as 0 volts right at that point right there. Now the fact that I have 1 amp through an 8 ohm resistor says that I have 8 volts between here and here. Now this is going to be 8 volts, and I'm going to put it relative to this point right here. I don't know what this voltage is because this is 0 and there's some voltage across here, and I'm going to call that 0 volts relative to this point right here. And I'm calling it volts relative because, again, I don't know. It's relative to this. So these are going to be relative to whatever this voltage is right here. I'll figure that out later. What I do know is that I've got 8 volts between here and here. Now, this may look a little tricky to you, and you might think that you have to use a delta Y transformation or Y delta transformation, but in this circuit, there's no place that we're going to need this delta Y transformation. Now I'll show you, we'll figure out why here in a moment. So if I have 8 volts between here and here, that means I've got 8 volts between this circuit right here as well. These two resistors are essentially a parallel circuit. So this is 40 ohms right here between these two. And if that's the case, I've got 40 ohms and 25 and 15, that's 40 ohms, these two, and 8 volts. 8 volts divided by 40 is this. That means I've got 0.2 amperes going through these two guys right here. 0.2 amps. Alright, so from here we can use KCL. We can figure out that I've got 2 currents coming out of this node right here that are 1.2 amps. So that means I need 1.2 amperes going in. Well, the 1.2 amperes going in says that +1 times 15 ohms says that I have 18 volts going across this guy right here. Right? From here to there. 18 volts. Well, the current is going from high voltage to low voltage. It's going this way. I've got 1.2 volts going out, 1.2 or amperes going out. I must have 1.2 amperes going in, which means that this is going to be 18 plus 8, which is going to be, this point here will be 26 volts relative. Okay, so let's redraw this little section of the circuit. I've got my 13 ohm resistor over here. I've got a 15 ohm right here. This is 26 volts relative. This one is... Now, I'm going to combine these guys right here all into one. So I've got 40 ohms in parallel with 8 ohms. And that means my R parallel is going to be equal to 1 over 8 plus 1 over 40. And that comes out to, well, let's see, 8, 1 over x plus 40, 1 over x equals, and then 1 over x, that is basically a 6.67 ohm resistor. Alright, so that's what all these three resistors just add up to. 26 volts relative, 8 volts relative, and then down here I have 0 volts relative. And that means that I can figure out now, we've already determined that there's 1.2 amps going this way, coming around this total, right? Now we can figure out the current going this way. 26 divided by 13 is going to be 2 amps going downward this way through this 13 ohm resistor. So that's going to be 2 amps going this way. So we kind of got that figured out. If we know that 2 amps is going in this way, now we're looking at the next little piece, this 5 ohm resistor. And then we can figure out what the true voltage is, because I've got 1.2 amps coming in this way, right? It's going through this loop, coming out 2 amps going in. That means I have 3.2 amps coming out, all using KCL. This is 5 ohms, right? So 3 times 5 is 15 plus 1 is, that means I've got a 16 volt drop, and that's going from 0 volts relative, from high to low, right? Because this is my 0 right here. So this is 16 volts between here and here. So whatever's volts relative to this, I've added to this. This is officially no longer 16 volts relative, is now, or no longer 0 volts relative, is now 16 volts. This 0 volts relative is 16 volts. 26 volts relative is going to be 42 volts. And then 8 volts relative is going to be 24 volts to the ground. Okay, so we've figured out quite a bit here. I've got 3.2 amps going this way, 2 amps going this way. We're going to expand the circuit a little bit more now. We have to look at it, but I do have 3.2 amps going in here. Alright, that means I've got, now I do know that this is 26 volts relative, which is 42 volts. So now 42 divided by 6.5 ohms is going to come out to 6.46 amps. So between here and here, I have 6.46 amperes going through this. I have 3.2 amperes coming in there, because this is going from 42 down to ground. What else can we figure out here? These two resistors become basically a resistor here. So here I have a 1 over 12 RT is equal to 1 over 25 plus 1 over 7, and that is 25 1 over x plus 7, 1 over x equals, and then 1 over x that, and it gives me 5.47 ohms roughly. I'm going to store that because that's going to give me an actual even number somewhere. So 5.47 ohms. I have another resistor right here, 9 ohms, and then of course the next resistor is 15 ohms. We still don't know what's going on over there. We do know that the 46.46 amperes going in this way. I suspect there's some current going this way, and then all the current going out is going this way into my supply. Okay, so the main current is supplied from the volt power supply. Now it's getting a little bit of scraggly here. So where can we go from here? Let's see, it's got 5.47 ohms right here and 42 volts. But here's another cool thing. I know how much current is going this way. I know that I've got 1.2 amps coming out here, 2 amps going up here. I've got 6.46 amps coming out here, and that tells me how much current is going in. Okay, so let's figure that out. I'm going to store that number. That's not going to help any, but I've got it stored anyway. So let's see, I've got 1.2 plus 2 amps plus 6.46 amps all going out of this node right here. Those add up to 9.66 amperes. So 9.66 times 5.47 is 52.8 volts going across here. So I've got 52.8 volts over here. And that means I'm adding that to my 42 volts right there, plus 42 equals, and that gives me 94.8 volts. And that's a 52.8 volt drop across this resistor, but the current's going from high to low, so we add that to this 42 volts, and that gives us 94.8 volts right here at this point. Okay, so 94.8 volts, and here I have a 9 ohm resistor, so divide by 9, and that gives me 10 amperes, 10.54 amperes going this direction. Okay, so I have 10.54 going here, and then plus 6.46 plus 3.2 equals. That means the total current coming out of this is going to be basically 2 amperes. And that means I've got 20.2 amps coming through. So that means I've got 20.2 amps going this way. And then I've got the 15 ohm resistor right here times 15 gives me 303 volts across this resistor, 303. And it's going from, again, from high to low because current is going this direction. So I add 303 plus 94.8. That says that my power supply is basically 398 volts, or 397.8. Okay. Now, The power through the 25 ohm resistor is pretty easy to figure out. We've already determined that it is basically, what did we say? It's 9.66 amperes. 9.66 times 547 ohms. It says it's a 52.8 volt drop. So it's across this resistor we have 52.8 volt drop across. Okay, and then we know the P equals IV, which is equal to also V squared over R. We know V squared, so we're going to square that. Divided by the resistance 25 says that it is 100, so P25 is equal to 111.7 watts, and we determined that Vs is equal to 397.8 volts. That solves this problem.
Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.